Hi, Tom Wall's Carbide Processors. Sitting here with a toothbrush in my pocket, if you were wondering. Went to the dentist last Wednesday. Today's Monday. But I carry it with me to brag, so people will notice. Want to talk about carbide tip loss. 37 years ago, 36 years ago, I guess, I started pre-tinning carbide tips in my garage. Jeff Hewitt at Systematic told me it'd be a good thing to do. And there was a big recession. I was tired of getting laid off. At that time, the carbide people would make them. Nobody really knew much about the surface. The customers would get them. If the customer didn't like them, they would contact the carbide company who would blame me. And I was the little guy in the middle. And when I was brought up, my dad was a big believer in whatever you do, do well. So I started research. And 36 years later, I think we're starting to get some answers. How to braise. We've done some really nice things with how to braise. Don Wallinger did a video for us on how to braise. It's just wonderful. This is the latest thing. In the last few months, some of the very best shops in the country. We're talking your sawmills, saw manufacturers, saw and tool shops that do a lot of resharpening are having trouble. Incidental tip loss. They'll do a 24th tooth saw and 3, 4, 5 of the tips will come off. They come off very easily, and so a 3 or 4, maybe 5, and that's all. The rest are on just about as good as you want. So we did not sell these tips. A guy who's a customer of ours and who also buys some directly from the tip manufacturer came in a couple weeks ago with a saw, and he's having this kind of a tip loss. He's also involved in some experimental data on how long a saw should run, cutting different kinds of lumber under different kinds of conditions. It's with him. He's working with the manager of a manager for a major timber company that's doing these. This is really important stuff. But anyway, he had this problem. He didn't know why. The guy is incredibly thorough. He's been through his whole operation, experienced brazier, the whole rest of it. So what I did is I got out my Dyno Light. You may have seen this before. This one's the cheap one for $100. You plug it in to the USB port on your computer, and there's LED lights in there. You can adjust the focus from about 30 to about 230. What I do is I'll set it down right on the edge of the tip like so, and you usually get a pretty good picture around 50 to 70 magnification, and then you get another real close-up around 250. You can get different magnifications if you lift it up a little bit to adjust the focal length. It gives you a nice picture. Here's one of the pictures that we saw. In this picture, okay, this is about a 50 magnification of the surface of the notch, the steel saw notch, after the tip had come off. Now we're talking about a tungsten carbide tip with braze alloy brazed to steel. That's all there is. There's steel, there's braze alloy, there's tungsten carbide. There are gold spots here and here, okay? That gold spot is braze alloy. Braze alloy stuck to the steel. You can see the gray in various places. That gray, see, the gray with the lines in it is basically the film, the coating, the treatment, whatever that was on top of the carbide. And here you can see the carbide. Okay, some of the carbide did stick, it didn't, but the braze alloy stuck to the steel. A lot of the surface treatment on the carbide stuck to the braze alloy, which was stuck to the steel. It came off the carbide. This weakened the whole thing enough so that the carbide ripped. Here's another picture with the Dynamite, and they make considerably better ones than my $100 cheapie, okay? It kind of reads the colors the best it can, depending on what's going on. These are yellow patches with braze alloy. The gray around it is, once again, it's coating or treatment that came off of the tip. And on the side of this, and it's very hard to see, on the side of this you can see broken carbide. This is another tip where braze alloy stuck to the steel. The coating pretty well stuck to the braze alloy, except where it didn't. The coating ripped off the carbide. It weakened what was attached well, so that the carbide broke. And here you can see a real, let's do it this way. You can see a real sweetheart of a picture. Now, this is broken carbide, all right? Right on the edge. This big chunk in here, the big flat area, is braze alloy. When you braze the tip in, you get more strength if you have kind of a little buttress, a little shoulder, whatever. When you grind the tip to make the saw, you grind down some of the braze alloy. You can see here the heat control was very, very good because the flow onto the steel plate was very minimal. You can see it was a good flow, so the plate was very clean. I didn't see any holes. Now there's maybe 2 little pinholes in the braze alloy, which are usually attributed to zinc boiling out. So this was an extremely good brazing job. The failure point here was in the coating the manufacturer put on the carbide. The coating, the treatment, whatever term you want to call it, that the manufacturer put on the carbide to make it braze well. The braze alloy flowed over the top and looked good, but the joint failed when they were sharpening it. So it's out there. And as I say, this is what's been happening in some of the very best shops. I've had big shots from the company come out here, and they explained to me all the problems they had with the powder and the mixing the powder and the pressing and the centering, because you bake them like cookies, and some are on the edge and some are in the middle, and on and on and on. It's extremely hard to do, but that's their problems, and they're supposed to fix those problems. They're supposed to have those under control. I believe in Taguchi. If you've never read Taguchi says everybody in the manufacturing process should be doing their job with the end user in mind. So if you are going to mix tungsten carbide powder, if you're going to press it, if you're going to center it, if you're going to treat it, if you're going to pre-tin it, the only real standard is how well does it work for the guy in the shop. If it does not work well for the guy who's using it, the guy who's got to build saws, the guy who's got to repair saws, it's bad. This assumes a certain amount of expertise on the part of the guy doing the work. But there's a lot more bad carbide that's blamed on the poor guy trying to braze it than is blamed on the carbide company, and that's where it is. As far as this carbide company, we sell a little of their stuff. They've got some grades that still work pretty well. This one we don't sell anymore. We sell one of their competitors' grades. You also have to be very careful because this grade was a really good grade until they ran out of the old batch. Then they started using the new batch, which was 3 years old. And this problem shows up in the new batch, so they said, well, tell people they can't use that in sawmills or those kind of applications anymore. Tell them to use it more like a C3, which is okay, except it's still not going to braze well. There's going to be a certain percentage that don't braze well. So Personally, I think they ought to scrap it. But that's it. We're at 10 minutes and the dog's hungry, and so am I. So thank you for listening. Bye.